Among the most common equilibria that we'll look at, and the most important, are acid-base equilibria. Acid-base equilibria involve transferring a proton from one species to another. Here I've written an example, very schematically. HA, a compound with a hydrogen, gives up that proton to the compound B. The compound B accepts the proton. Now, I'm saying proton. By that I mean when this hydrogen leaves the HA compound, it leaves its electron behind. So it's only the nucleus of the hydrogen that leaves. And the nucleus of a hydrogen atom is a proton. So we call this proton transfer. A proton is transferred from A to B. A acts as an acid and becomes a base. B acts like a base and becomes an acid. Now, why do I say that, becomes an acid? Because this is an equilibrium, and I can go in this direction too, and when the reaction goes back in this direction, it's BH plus that's acting as the acid, donating a proton, and it's A minus acting as a base, accepting a proton. So that'll be our definition of acid and base. If you give up a proton, you act as an acid. If you accept a proton, you act as a base. Here's some examples of acids, HA compounds. H2O, water can give up one of its protons and act as an acid. HAC, that's an abbreviation for acetic acid. That's really H3CCOOH. So I've abbreviated significantly here, and of those 4 hydrogens, only one is donated as a proton. One is the acidic proton on acetic acid. H3O+, that's water with a proton added. So it has an extra proton, and it will very readily donate that one. So this is quite a strong acid. You can think about the conjugate bases, the corresponding bases, these compounds after they've donated a proton. So here's H2O, the conjugate base of H3O+. So water can act as an acid or a base. Here's AC-, the acetate ion, after it has donated a proton, and OH-, water, after it has donated a proton and acted like a base. So here would be water donating a proton. You'd have OH- left over, and that can act like a base when it accepts a proton in the reverse direction. Here are some classic bases. H2O, water, can act as a base. When it accepts a proton, it becomes H3O+, the acid. NH3, it can accept a proton, act as a base, and OH-, as we've already discussed, the strongest of these 3 bases, the most able to take a proton. If you take a proton, you accept it, you're a base. Here's the conjugate acids of these bases. H2O, the conjugate acid, NH4+, the conjugate acid here of NH3, and H3O+, the conjugate acid of H2O. So our definition, an acid gives up a proton, a base accepts a proton. Acid-base equilibria.